So after 10 mils of acid, we've not got to the equivalence point yet. But what we have done is generated some acetate, some of the conjugate base. So now we have a weak acid conjugate base. It's a buffer, which is why we call this the buffer region. So the first thing we need to do is to find out how much acid and base is in solution. So we're going to look at acetic acid. When you add a strong base to it, it pretty much goes completely. It will form the acetate and water. So we're going to lose some of the acetic acid and generate some acetate, and then it's going to come to equilibrium. So what we want to do is find out those initial concentrations first. So the initial concentration of acid, I'm just going to call HA. We're going to have however number of moles that we started with, which was 0.1 times 0.1 molar times 0.05 liters. You can keep that in milliliters if you want, it doesn't make any difference. And then we're going to subtract the number of moles of base that we've added. Because it's a 1-to-1 ratio, every mole of hydroxide is going to react with one acetic acid to make one acetate. So we've got 0.2 times 10 milliliters, or 0.01 liters of base. So that will tell you how many moles of acetic acid are left. Divide that by the total volume. Remember, we've increased the volume, so we're essentially diluting everything. So it's going to be 60 milliliters, 50 plus 10, and that gives us a concentration of 0.05 molar. Okay, that'll be our initial starting concentration of acetic acid. For acetate, every mole of hydroxide is going to make 1 mole of acetate. So we just need to find out the number of moles of hydroxide added, and that was 0.2 molar. We've added 10 milliliters, or 0.01 liters. And again, the volume's increased, so we have to take that into account. So the total volume is again going to be 60 milliliters, or 0.06 liters. And that will give us a concentration of 0.0333 molar. Run out of space there. Okay, so now we know our initial concentration of acetic acid and acetate. Now has to come to equilibrium. Now if you want to memorize the Henderson-Hasselbalch equation, you can do that. I generally don't like to memorize, so what I would do is just put this into an ice table. So acetic acid, we'll do the acid dissociation for acetic acid. So that will make acetate and the hydronium ion. That's what we're trying to find, initial change in equilibrium. So what we just calculated were our initial concentrations. So acetic acid was 0.05. Acetate was 0.0333. No H4 plus. The change will be minus x plus x plus x. It's all 1-to-1 ratio. So the equilibrium concentration will be 0.05 minus x for acetic acid, 0.0333 plus x for acetate, and x for H4 plus. And we'll put that into the Ka value for acetic acid, and that will be I'm going to say again, because the Ka, remember, is 1.75 times 10 to the minus 5, x is going to be small in comparison to 0.05 and 0.03, so I'm going to ignore those values and say that it's a reasonable approximation. Ka is going to be 0.03, or the concentration of the products, 0.033 x divided by 0.05, and we know the value of Ka is 1.75 times 10 to the minus 5. So we can solve for x, which is our H4 plus concentration, and that's going to be 2.63 times 10 to the minus 5 molar. So again, we would expect the pH somewhere around 5, a little below 5. It ends up being 4.58, just taking the negative log of that concentration.